Hello, and welcome back to IntelligentPod. I'm your host, Sophie Lane, and as always, I'm thrilled to have you joining me for another deep dive into the fascinating worlds where technology, science, and human curiosity collide. Today, we're tackling a topic that's been popping up everywhere from TED Talks to tech blogs to coffee shop conversations, but still feels wrapped in a cloud of mystery for most people. Quantum computing. Yes, you heard me right. Quantum computing. If you've ever found yourself nodding along when someone mentions qubits, entanglement, or quantum supremacy, but secretly had no idea what they were talking about, you are absolutely not alone. In fact, you're in the majority. Quantum computing is one of those subjects that sounds both futuristic and intimidating. But here's the good news. By the end of this episode, you'll not only have a clear sense of what quantum computing is, but also why it matters, and how it could impact your everyday life far sooner than you might think. So let's demystify quantum computing together. Let's start at the beginning. What exactly is quantum computing? And why is there so much buzz about it? Traditional computers, the kind you and I use every day, are built on bits. These bits are the smallest units of information and can be either a 0 or a 1. If you think of them as tiny switches, they're either off or on. Every app, photo, email, and website you use is ultimately built from billions of these little bits flipping back and forth. Quantum computers, on the other hand, use something called qubits, short for quantum bits. Here's where it gets wild. Thanks to the peculiar rules of quantum mechanics, a qubit can be both 0 and 1 at the same time. This property is called superposition. Imagine if you could be at home and at work at once. Sounds impossible, right? But that's essentially what a qubit does. Now add another quantum property called entanglement. When qubits become entangled, the state of one instantly influences the state of another, no matter how far apart they are. It's like having two dice that always land on the same number, even if you roll them in different cities. Because of these two properties, superposition and entanglement, quantum computers can process massive amounts of information in parallel. Rather than one calculation at a time, like traditional computers, this opens up possibilities for solving problems that would take even the fastest supercomputers today millions of years to crack. Let's sprinkle in a quick statistic. According to IBM, a calculation that would take the world's fastest supercomputer 10,000 years could potentially be done by a quantum computer in just minutes. That's the kind of leap we're talking about here. Now, you might be thinking, Sophie, this all sounds amazing, but what does it mean for me? Where will I see quantum computing in my life? Great question. Let's break it down with some relatable examples. Imagine searching for a new medicine. Right now, it's a process of trial and error, testing one molecule at a time. With quantum computing, we could simulate and analyze millions of molecules simultaneously, dramatically speeding up drug discovery. Or think about online security. Quantum computers had the potential to break many of today's encryption methods, but they could also create new, virtually unbreakable security systems. Even traffic. Quantum algorithms could optimize everything from shipping routes to city traffic lights, making our daily commutes smoother. All right, so now that we've set the stage, let's explore quantum computing through a few different lenses: psychological, scientific, and cultural. First, the psychological perspective. Why does quantum computing feel so daunting to so many of us? Well, part of it is the language. Quantum mechanics, the science underpinning quantum computers, deals with concepts that run counter to our everyday experience. In the quantum world, particles can be in multiple places at once, and measuring something can change its reality. Our brains are wired for classical physics. Things are either here or there, on or off. So, when we try to wrap our heads around superposition or entanglement, it feels like a mental gymnastic routine. There's also a phenomenon called technological anxiety. When new technologies emerge, especially those that are hard to visualize, people often feel a mixture of excitement and fear. Remember in the early days of the internet or artificial intelligence? There was a lot of hand-wringing, along with optimism. Quantum computing is going through a similar phase. The more we understand, the less mysterious and scary it becomes. Now, let's switch to the scientific perspective. Quantum computing is, at its core, a triumph of human ingenuity and persistence. The foundational math and physics date back to the early 20th century, with pioneers like Niels Bohr and Albert Einstein. But it wasn't until the 1980s that physicist Richard Feynman suggested building computers that use quantum mechanics to simulate other quantum systems, essentially fighting fire with fire. Fast forward to today, companies like Google, IBM, and startups like Rigetti and IonQ are racing to build practical quantum computers. In 2019, Google announced it had achieved quantum supremacy, meaning their quantum computer solved a problem no classical computer could manage in a reasonable timeframe. This sparked both excitement and skepticism in the scientific community. Some argued the problem solved wasn't very practical, but it was a milestone nonetheless. Academic studies are pouring in, and here's one I find fascinating. In 2022, researchers at the University of Science and Technology of China used a quantum computer to solve a complex problem related to quantum chemistry in just a few minutes, a task that would have taken a traditional computer years. This is a glimpse into the kinds of breakthroughs we might see in everything from climate modeling to materials science. From a cultural perspective, quantum computing is already making its mark. Popular shows like Devs or movies like Ant-Man and the Wasp weave quantum concepts into their storylines, even if they take some creative liberties. There's a growing ecosystem of podcasts, YouTube channels, and even TikToks dedicated to translating quantum jargon into plain English. Communities are forming around open-source quantum programming languages. Yes, you can actually try your hand at writing quantum algorithms from your laptop at home. But let's not overlook the ethical and societal questions. Who gets access to this technology? Will quantum computing widen the gap between tech superpowers and everyone else? How do we safeguard privacy in a world where our current encryption could be obsolete? These are the kinds of conversations happening in universities and policy circles right now. Let me share a real-life anecdote that brings all this closer to home. I have a friend, Alex, who teaches high school computer science. Last year, she started a quantum computing club at her school. She expected maybe a handful of students to join, but over 40 kids signed up, eager to learn not just how quantum computers work, but how they might shape their future careers. Alex told me one student, Maya, was fascinated by the idea of using quantum algorithms to tackle climate change. She's now planning to study quantum physics in college. This next generation isn't intimidated, they're inspired. Now let's pivot to something practical. You might be wondering, okay, Sophie, this is all fascinating, but what can I actually do with this knowledge? Here are some actionable tips, whether you're a tech enthusiast, a lifelong learner, or just quantum curious. 1. Don't be afraid to ask basic questions. The quantum world is weird and no one expects you to get it all at once. Embrace your curiosity and ask away. 2. Explore quantum computing resources for beginners. Websites like IBM's Quantum Experience let you run simple quantum programs in your browser. No PhD required. There are also fantastic books and YouTube channels dedicated to demystifying these topics. 3. Follow the news, but with a critical eye. There's a lot of hype in the quantum space, and not every breakthrough is as world-changing as the press release claims. Look for reputable sources and balanced reporting. 4. Think about the bigger picture. Quantum computing isn't just about faster computers. It's about reimagining how we solve problems, protect data, and understand our universe. Stay open to the ethical and societal conversations too. 5. If you're an educator or parent, encourage curiosity in STEM fields. The next Maya might be in your classroom or your living room, waiting for that spark of inspiration. All right, let's take a moment to recap. Today, we've peeled back the layers on quantum computing, what it is, how it's different from classical computing, and why it matters. We looked at the psychological hurdles, the scientific milestones, and the cultural conversations happening around this technology. We heard how it's already inspiring young minds and discussed some simple steps you can take to engage with this new frontier. If there's one thing I hope you'll take away from today, it's this. Quantum computing doesn't have to be intimidating or out of reach. At its heart, it's a testament to human curiosity, the very drive that brought us the light bulb, the airplane, and the smartphone. Quantum computing is the next chapter. And you have every right to be a part of the story. Before we wrap up, I'd love to hear your thoughts. Did something about quantum computing finally click for you today? Are you excited, skeptical, or maybe a bit of both? You can always reach me at sophie@intelligentpod.com. I read every message and love hearing from you. If you enjoyed this episode, please consider leaving a review wherever you listen to podcasts. It helps new listeners discover the show and lets me know what topics resonate with you. And for detailed show notes, links to resources, and more, head over to IntelligentPod.com. Thank you so much for joining me on this quantum adventure. Until next time, I'm Sophie Lane, and this is Intelligent Pod, where curiosity meets clarity. Stay curious, stay inspired, and I'll see you in the next episode.